Welcome back to Tightwad Workshop. Today we're going to be restoring this bench grinder to operational condition. I can turn its wheels by hand, but it does have a little bit of drag in it. Its electrical safety test was done fairly recently, so let's plug it in and see if it works. So as you can see, those bearings are a little bit too stiff to allow the motor to get it started. Given the age of this machine, I think it's most likely going to be caused by worn out bearings. So let's get started on dismantling it to find out. I don't want to get my bench top dirty, so I'll staple some paper over it first. This is the backing paper from a roll of self-adhesive plastic film, so it should be fairly grease resistant. The wheel on the left side of this grinder uses a nut with a left-handed thread. That means it tightens in the lefty-locky direction and unscrews with righty-removey. If the grinding wheel won't slip off easily, you might need to lever it with a screwdriver. Just make sure that you lever against the metal washer, not the stone wheel. The wheel on the right side uses a normal lefty-loosey, righty-tighty thread. The wheel guards at each end are held on with 3 screws. The motor end caps are held on with 4 screws each. I'll remove the screws from the other end as well. Now I can use a soft-faced hammer to loosen the motor end caps. That front cap was stuck really tight, so I used a screwdriver to lever it loose. The back cap was much easier to remove. But the one on the front needed some extra attention from the hammer. This paint on the motor shaft is almost certainly the cause of the problem. It looks like this motor uses semi-sealed bearings. The rotor has some shiny areas, so it might have been rubbing on the stator. This is a sign that the bearings might be worn out. There's some dirt and dust on the stator, and I'll wipe that clean before we reassemble the motor. This clicking noise is another sign that this bearing's worn out. The other bearing's making the same noise, so very likely they're both bad. Some manufacturers will leave a small hole in the housing so that you can use a small punch to drive out the old bearings, but this time we'll need to use a big punch and hammer against the centre of the bearing. So if the bearings weren't bad before, they definitely will be after we finish driving them out. I'll drive out the other bearing in the same way. Now we can clean off the old bearing and try to identify it. It looks like this is a 6202 Zulu bearing. I keep a box of replacement bearings in this drawer. It looks like we're lucky. I have a whole roll of 6202 Zulu bearings in stock. Now we can clean out the bearing housing with some solvent and a toothbrush. This is a dirty job, so it's best to use somebody else's toothbrush. I've found a socket with the same diameter as the bearing. We'll use this as a punch to drive the new bearing in. It's important that you only put pressure on the outside ring of the bearing while you hammer it into place. If you hit the inner ring, you'll destroy the new bearing, like we did while removing the old ones. This one sounds much better. The motor housing has this bracket, which prevents you from installing the rotor the wrong way round. Let's refit the front motor cap in place first. I'll need to tap the rotor shaft until it's all the way through the bearing. Now we can install the second end cap. I forgot to mention that these ventilation holes need to be at the bottom. Now I'll tap the second cap gently into position. The shaft is turning freely, so we must be doing it right so far. Now we can reinstall the 4 screws for this end. These wheel guards do 2 main things for us. First, they give us an attachment point for the tool rests. Second, they give us a small amount of protection if a grinding wheel breaks apart while we're using it. You can imagine the forces involved if this stone breaks apart while it's spinning at 3000 RPM. Luckily, this particular stone broke when I dropped it on the floor, but operational failures can still sometimes happen. The outer covers were missing from these guards, so we'll make some replacements using this metal sheet. I'll just unbolt the tool rest so that I can trace this one. I'll trace the outline using this marker pen. We'll also need a hole in the middle of the plate. I'll explain why in a minute. I'll just rough cut these parts outside using an angle grinder. Once we've finished roughing out the parts, I'll use a file to remove any sharp edges and points. That first sector looks good, so I'll turn it around in the vise and keep going on the next one. Next, I'll centre punch and drill the mounting holes. This is why we need that hole in the middle. The motor shaft needs to stick out through the end plate. I'll attach the end plate to this piece of wood to hold it safely while we chain drill the big hole. Chain drilling is a way to make a big hole in metal if you don't have a big drill bit or a hole saw. Now we can take our workpiece to the vise and break out the centre. I really should have used pliers to do this. Next I'll use a round file to smooth the inner edge of the hole. The part of the workpiece that's sticking up from the vise is vibrating and ringing like a bell, so I'm wearing earmuffs. Our file has left a burr on the opposite side of the workpiece, so we'll take it out of the vise and file it smooth. Now we've run into a problem. The hole isn't big enough to clear these washers. The easiest way to mark the correct size of the hole is to remove the washer like this, bolt our end plate into position, refit the washer and nut, then use our marker to draw around it. We'll use the chain drilling method on the bigger hole, the same as we did before. Then repeat the same centre breakout and filing procedure. Now our plate has enough clearance to let the wheel spin. I'll use this cap to cover the end of the motor shaft. These caps are used on the ends of steel pipe fence posts. I don't want it to stick out this much, so I'll saw it off about here. That should work just fine. Now we can look at the tool rests. This one is homemade, and this one is an original part, but it has a crack. The homemade part looks good, so we'll use it as a pattern and make a second one. I'll just take this out to the angle grinder station and rough it out. And here's the roughed out part. These two parts need to be mirror images of each other, so I'll mark the fold line on this one here. Next I'll file all the sharp edges smooth, then put the part in the vise and bend it at the fold line. I'll use a hammer to bend it down to a 90-degree angle. Now we can go outside to the welding bench and weld our parts together. So it looks like the grinder wheels still have enough clearance to spin, but I'm not proud of these ugly welds. The thin galvanised caps didn't want to cooperate with me, so I'll cover my shame with a nice thick coat of paint. This paint is Hammertone finish, which is forgiving of bad brushwork. I'll also paint the sides and fronts of the tool rests. It's winter here in Canberra, and since I don't want to have to wait multiple days for the paint to dry, I'll put the parts in my workshop oven. I rescued this oven from somebody's house renovation. Only one of its heating elements still works, but it's still useful for jobs like this. I'll select about 70 degrees Celsius, that's about 160 Fahrenheit, then turn it on. So the parts have a rather poor finish, probably because of my inadequate surface preparation. But it's okay, because that's still a good match for the rest of the grinder. Let's go ahead and bolt on the end plates and tool rests. It's always a good idea to check for clearance after you've adjusted a tool rest. Okay, so here's the big moment you've all been waiting for. There's a little vibration, and I think it's mostly because that right side wheel isn't quite seated correctly. I'll fix that for our next video. Speaking of our next video, in that one I'll be dressing the grinding stones with this special tool, then making a start on sharpening some of my stockpile of blunt drill bits. That's all for now. Thanks for watching. Tightwad Workshop is filmed in front of a live studio audience.